So let's perform k-fold cross-validation on digits dataset. So here is the question that I will try to answer. Which machine learning model should I use to classify digits dataset? And now let's load our dataset. So Scikit-learn, it provides you libraries to load these digits, and the method is load digits right here. So I'm loading the digits, I'm storing that in the variable digits, and then I'm separating this into independent variables and dependent variables. My x in this case would be my independent variables, and y would represent your dependent variable. This actually also another name for that for your y variable is response variable, target variable. These are other names for that. For independent variable, another name would be features. So let's view the first image. I create my index equal to 0. This is the first image. And I print the independent variable, so x square bracket idx, and I also print its corresponding label right here. So these are the pixel values for the first image right here. And this one is the label for this pixel value right here. Now let's view the image on this screen. Let's render the image. So in this case, I'm using matplotlib library. I'm also importing numpy. So first thing I'm doing, I'm creating my index for my first image. This is index 0. That's my first image. And then this code right here is responsible for rendering the image. I'm also putting numbers on the image. I want to see what the pixel value of each image is. And when I run this cell, that's going to give me this image right here. So each one of the numbers on these pixels, they represent the grayscale level. 0 means black and 16 means white. So the number is going to be between 0 to 16. In this case, you can see that there are total 8 rows, 8 pixels in this direction and 8 pixels down. Total 64 columns or 64 cells, sorry. So there'll be 64 cells for each image, for each digit. Now let's take a look how many rows and columns I have. So in this case, I'm printing x dot shape, and that gives me this number. So the first one represents how many rows. In other words, how many images I have. I have 1,797 images, and each image has 64 features. In other words, 64 pixels or 64 columns. This is columns right here. Now, let's try to find a best model without using cross validation. So first thing I'm doing, I'm importing my train test split function. This is responsible for splitting your data into training and testing. Now let's feed our data to logistic regression model first. So first thing I'm doing, I'm importing my necessary model. In this case, I'm importing logistic regression model. This is a classifier model, by the way, and I'm supplying necessary hyperparameters. I'm just picking these hyperparameters randomly. So I train my model. That's what this inbuilt method fit. That's what it does. And then I'm checking the score right here. So it just prints out the score. So when I run this, it gives me the score of 90.98. So 90.98 percentage, that's your accuracy for this particular model. Now let's do the same thing with SVM. So in this case, I'm using classifier for support vector, and I'm using this hyperparameter right here, and I'm training my model right here, and then I'm printing the score. And when I run this, it gives me the score of 51.25. Not a great score, horrible score. Now let's do the same thing with random forest. So in this case, I'm picking a random forest classifier. I'm supplying number of estimators, in other words, number of trees, and I'm training the model right here. And then I'm printing the score, what the score is going to be. And when I run this, it gives me the score of 92.65. So between 92.65 and 51.25 and 90.98, it seems like your random forest classifier is doing good over here. Now we are going to perform k-fold cross-validation. Scikit-learn package has a function, cross-val score. This function is responsible for performing k-fold cross-validation. So first thing we do is import that function. Now let's look at the logistic regression model performance using your cross-validation score function. So first thing I do, I create the model, the logistic regression model, and I'm using these as my hyperparameters. You could have picked up any other. I just picked up these just to show you the proof of concept. So I pick up these hyperparameters, then I feed my model to your cross validation score. So I give it like parameter right there. This is my input parameter. And then also you give your X, which is your independent features. Also supply your Y, which is your response or target variable. Also specify how many fold you want. In this case, I want 3 fold. So it's going to give me 3 scores for each fold. And then I print out those scores right here. And also printing out the average for those scores, average for all 3 of them. So these are the corresponding scores for all 3 folds right here. and this is the average for all these three scores. Now I do the same thing for your SVM model. I want to see how exactly it performs using cross validation score. So in this case, my support vector classifier, I'm using that. Giving it a hyperparameter gamma equal to auto, and I'm calling the same function right here, exactly same function. The only thing I'm just changing the model name. In this case, I'm using model SVC, and my X and Y and CV, everything is same. Again, in this case, there are threefold, so it's going to give me three different scores. I print those three different scores, and I'm also printing the average for those SVC. So in this case, these are the three scores for each fold, and then I'm printing the average. And look at this average. Oh, not looking good. Only 43.46. In other words, it's 43% accurate. Okay, now let's do the same thing for random forest. Let's look at the random forest performance using cross validation. So first I'm creating my random forest classifier. In this case, I'm using 40 trees. Number of estimators is 40. That's what it means. And then I'm feeding this model RFC to your cross validation score. So I'm feeding this over there. I'm also giving X and Y. Everything I'm keeping same except this model name. And then it's going to print out three different scores for each one of these fold. When I run this, it's going to print out the scores and also print out the average. And look at that, average is 93.48. So between RFC, which is your random forest classifier, look at the score and look at this score and looking at this score, it seems like random forest classifier is doing pretty good. So in this case, conclusion is that random forest classifier is better than all of the above. By the way, on a side note, your cross validation score by default it uses stratified k-fold. Now, let's perform hyperparameter tuning using k-fold cross-validation on the random forest classifier, the classifier that we picked over here. The one that we found is doing a good job. So here I'll be tuning the hyperparameter n estimators. N estimators refers to number of trees. I'll be changing it to 5, 20, 30, 40 and try to see which one gives me better score. So first I'm using random forest classifier with number of estimators as 5. I'm feeding my X and I'm also feeding Y, and this time I'm keeping cross validation as 10. So let's run this and let's see what is the average score, and the average score is 86.86. So 86%, approximately 86.86%. So this one gave me this score right here. Now let's do the same thing with number of estimators as 20. So this is exactly same as this right here. The only difference is I'm just changing this number of trees now to 20. So let's run this and let's see what it gives me the average. And the average score is 93. So you can see it went up from 86 to 93. All right, that's good. Now let's change our number of estimators to 30. So everything is same except I'm just changing this to 30. So let's run this and let's see what's the average score. And the answer comes out to be 94. All right, so the numbers are going up. You can see that 86%, 93%, 94%. Now let's change it to 40. So let's make our number of trees to be 40 and let's see what it does. And in this case, it gives me 93. Well, it did not really went up. It actually went down. So it seems like our number of estimated 30, that seems to be just about a right number. So conclusion is this, that the random forest classifier with 30 trees, it gives you the best result on digits dataset. So using your k-fold cross validation, I was able to find the best model and also the right hyperparameter. So in this case, this right here hyperparameter is the right hyperparameter.